So today we're doing lesson 16, solving quadratics. Please make sure you have a worksheet from the substitute and then we can get started. Okay, so we're looking today at perfect squares. So right here in front of us I have x squared plus 8x plus 16 and it's equivalent to x plus 4 squared. So what we want to do is we want to figure out how does the one become the other? So 4 squared is 16. 2 times 4 is 8. Also, I should make note, I recorded this the first time without sound, so I am now speaking over my previous recording, so I'm sorry if sometimes my speech is slightly off. So this is our warm-up. So 16 is 4 squared. 8 is 2 times 4. So that's where the 4 is coming from. So on these ones below us, we want to figure out which ones can be that form of a perfect square. And so if I'm looking at the first one, that 25 and that 10, I want to see, are they related? Well, I know 25 is a perfect square. 25 is a number 5 squared. I know that 10 is 2 times 5. And so since 25 is 5 squared and 10 is 2 times 5, it's a perfect square of x plus 5 squared. As I go on and look at the others, I want to ask myself, can I square that number on the end? And so on number 2, is there a number that when I square it is 29? Well, there's nothing that when I square it is 29, so that one is not a perfect square. 3, I do the same thing about 8, and nothing squared is 8. But on 4, there is a number that when I square it is 9. The number 3 when I square it is 9. So 3 squared and 2 times 3. Now, but notice there's a minus in the middle. So really, this is a 2 times a negative 3. This is a negative 3 squared. But when you square a negative, you still get a positive. So where you just have to be careful is when you write your perfect square, you need to make sure there's a minus in the middle. The minus in the middle comes from the minus in the middle with the negative 6. So these are my perfect squares. Now we're going to be comparing two different ways that Elena and Han solve the same problem. They're using methods from Algebra 1, but it's been a long time since we've seen these, so we're just hoping to reactivate our knowledge of them. So they're trying to solve the equation x squared minus 6x plus 7 equals 0. So Elena said that she's first going to add 2 to each side. And so that tells me that x minus 3 squared equals 2. And once she has that x minus 3 squared equals 2, she's got to get rid of the square. Well, remember that when you take the square root of a square, you need a positive and a negative root. So you need a plus or minus square root of 2 when she does that. So that's where the x minus 3 equals plus or minus square root of 2 is coming from. Plus or minus means you have a positive and a negative root to it. She's trying to get x by itself, so she adds 3 to both sides. So she has 3 plus or minus the square root of 2, and then splits it into two answers, 3 plus the square root of 2 and 3 minus the square root of 2. So these are Elena's answers. Han uses a different method. Han uses something called the quadratic formula. The quadratic formula is really, really important, guys. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So he's using that formula, and so he says his a is 1, his b is negative 6, and his c is 7. These come from the coefficients of your formula. So a is the number in front of x squared, b is your number in front of x, c is a constant on the end. Keep in mind, to use this formula, it must be equal to 0. You must get your quadratic equation equal to 0. So then we plug it all into the quadratic formula. And so notice the positive 6 is because it was negative b, and negative 6 is positive 6. When you simplify under the square root, that whole thing simplifies to be 8. So we have 6 plus or minus the square root of 8 over 2. He decides to split this fraction up to simplify it, so he gets 6 over 2 plus or minus the square root of 8 over 2. And 6 over 2 becomes that 3. And square root of 8 over 2 he leaves as such. And so then he breaks it into his two answers. So pause the video for a minute and try to decide if you agree with one of them or if you disagree and who you think has the right answer. At the end of 1 minute, go ahead and hit play again. Okay, so as we're looking at it, something I want us to think about is, what is the square root of 8? So the square root of 8, does it have a perfect square living within it? And so the square root of 8 is the square root of 4 times 2. And the reason we do this is the square root of 4 is a number I know. The square root of 4 is 2. So I get 2 square root of 2. If I then rewrite Han's answer, I'm going to get 3 plus or minus 2 square root of 2 over 2. And at this point, the 2's cancel. So that 2 cancels, and I'm left with 3 plus or minus square root of 2. Notice this is the same answer that Elena had. So Han and Elena are ending up with the same answer. All right, so they are the same answer. So both actually, they just have different representations of the same answer. They are equivalent. Both of them are correct. They are just at different levels of simplification. All right, so Han's method was called the quadratic formula. The quadratic formula works 100% of the time. Quadratic formula will always work. So it's a really beneficial formula. The one thing to keep in mind though with the quadratic formula is your equation must be equal to 0. To use it, your equation must be equal to 0. All right, up here it's called completing the square. The method she is using is called completing the square. So completing the square is to try to create that perfect square that we saw in the warm-up. So for example, I know that -6 is 2 times 3. And so I want to have 3 squared on the end. But 7 on its own is not 3 squared. So we need to make it 9. How do I turn 7 into 9? I add 2 to both sides. And then you can factor your perfect square trinomial, which is where x minus 3 squared comes from. After that point, you have to take the square root to get x minus 3 by itself. And so that's where the rest of her steps are coming from. So the big thing there is to complete the square. You're trying to make that number on the end your perfect square for half your middle term. Completing the square works nicest when your x term is even. It is very, very messy when your middle term is odd. Quadratic formula works in any situation. So most of the time you will find me using the quadratic formula. All right, so you're going to work on solving these problems. What I would recommend doing is maybe hit pause, try some problems, and then hit play again and check your answer. All right, if you get stuck, hit play, get some ideas, and then see if you can finish it off. So do a lot of pausing and playing so that way you can get a chance to try it on your own and also see examples. If we're looking at x squared equals 100, I'm actually going to approach this like we did at the beginning of our whole unit, which is to just take the square root. Since it's just a square equal to a number, I think taking a square root is the simplest way to approach this problem. So if I'm going to go take the square root of both sides, remember that when I take the square root of a square, I need the positive or negative. So I need the plus or minus. So x equals plus or minus the square root of 100. And the square root of 100, though, is 10. So I get plus or minus 10. All right, so number 2 is the same thing. So I get plus or minus the square root of 38. But this time, square root of 38 is not a perfect square. 38 is 19 times 2. 19 and 2 can't simplify. So I'm just done. That's the answer. I can't simplify it any further. It's just plus or minus the square root of 38. Now number 3, 100% you can use the quadratic formula. But this one does happen to look really nice like a perfect square. So I'm going to go ahead and solve it like a perfect square just because it already meets that structure. So 25 is 5 squared, where 10 is 2 times 5. So that means I can go straight to factoring it as x minus 5 squared. Since I have a quantity squared, I can simplify that by taking the square root of both sides. Now when I take the square root, I put plus or minus. But keep in mind, the square root of 0 is just 0. And so plus or minus 0, they're the same number. So this just is x minus 5 equals 0. Now that I have that, I need to get x by itself. To get x by itself, I'm going to add 5 to both sides.
Matt Johnson, please contact Roberta.
So
So
now that I add 5 to both sides, x equals 5. All right, so the next one, I'm going to go ahead and use the quadratic formula. So I'm going to go ahead and write out the quadratic formula for myself on the side. And so my quadratic formula is going to be x equals minus b plus or minus the square root x equals minus b plus or minus the square root of b squared minus 4a times c all over 2 times a. And so on this first one, our a is the number in front of x squared, b in front of x, and c is on the end. Notice it's already equal to 0. Okay, so it's important that it's equal to 0. Our a in this case is actually 1. So if you don't see a number in front of x squared, that's actually 1. My b here is 14, and my c is 40. So I'm going to get x equals negative 14 plus or minus the square root of 14 squared minus 4 times 1 times 40 all over 2 times 1. And so then I'm just going to work on simplifying it. Feel free to use a calculator to help you with simplifying. So for example, in the calculator, 14 squared becomes 196. Minus 4 times 40 is 160 all over 2. So I get 36. And now I'm going to simplify the square root of 36 to be 6. I break apart my fraction. So I put each part over the denominator. So I get negative 14 over 2. And I get 6 over 2. So that becomes negative 7 plus or minus 3. Now the plus or minus 3 actually means I get 2 answers. So I'm going to break this apart into 2 things, one with a plus 3 and one with a minus 3. And these will both be solutions for x. So negative 7 plus 3 becomes negative 4. Negative 7 minus 3 becomes negative 10. There's my answer. So it does take a bit of work, all right, but just take your time and be careful about plugging it. So on number 5, my a is again in front of x squared, so it's 1. My b is in front of x, it's 14 again. But now my c is 39. So I'm going to go ahead and plug into my quadratic formula. So the difference this time is that my c is 39. So when I go to simplify, I still have 14 squared is 196, but now I have it minus 156. And again, feel free to use your calculator to find that amount. So 4 times 1 times 39 is 156. All right, now I forgot at first in the middle there, that should have been a plus or minus. So that's negative 14 plus or minus up there. All right, so I get the square root of 40. Now the square root of 40 is not a perfect square root, but it can be simplified. 40 is 4 times 10. The reason 4 times 10 is a nice way to break it is because I know what the square root of 4 is. I know the square root of 4 is 2. So now I can break apart this fraction into two fractions. Negative 14 divided by 2 plus or minus 2 root 2 divided by 2. And I get negative 7 plus or minus the square root of 10. And that one you would leave your answer like that. I can't simplify it any further. Now number 6, feel free to try out as a challenge problem, but otherwise we're going to go ahead and move on to the lesson summary at this point. So you do not have to do number 6. It is there as a challenge if you choose. All right, so we are moving on to the lesson summary. All right, so we had two methods today, completing the square and quadratic formula. Completing the square is all about making this perfect square. So I want to have 2 times the middle and that number squared on the end. So to find it, you end up doing half of whatever the x term is. So in this one, it's negative 5, so it becomes negative 5 over 2. So here's an example of it, and this example also shows you how messy it can get when your middle term is odd. You end up with these really kind of big fractions. All right, so here's an example of completing the square. Completing the square is a good method, but it doesn't work all the time. It gets really messy work. And so most of the time, I'm actually going to fall back on the quadratic formula. Notice it says that quadratic formula tends to be the most efficient. So the quadratic formula, a big thing with it is you need to make sure your equation is equal to 0. So for the quadratic formula, you're going to need to make sure you manipulate it so your equation is equal to 0. And so your quadratic formula is something you need to memorize. In Algebra 1, you were asked to memorize it. It's been a long time. Here it is again. I am asking you to memorize it. X equals negative b plus or minus square root b squared minus 4ac over 2a. Completing the square is something nice to know. Quadratic formula is something you must know. All right, so this is a must, especially if we're moving on to other math classes. So I want you to notice here that they made the equation equal to 0. They subtracted 0.8 to the other side to get it equal to 0. All right, so my A was 3. My B is negative 2. And so now my C is negative 0.8. So it had to be equal to 0 before you could plug it in. All right, and so our calculator had our values because this already had decimals in it. So we get negative 0.281 and 0.948. So we're going to move on to our cumulative practice. Today for the cumulative practice problems, I want you to do number 1, number 2, number 3, 1, 2, 3, I'd also like you to do number 5, so 1, 2, 3, number 5, and if time allows, please do number 7. So do number 1, 2, 3, and 5, and if time allows, go and do number 7. At this point, I'd recommend pausing and trying these problems, and then hit play when you're ready to check your work. There will also be an answer key at the front of the board. All right, so go ahead, pause, get started, hit play when you want to review your answers, or check the answer key at the front of the board. So on number 1, we're trying to create a perfect square, so I want to figure out 2 times what is negative 15. I know 2 times 15 over 2 is 15, because the 2's would cancel. So 15 over 2 is 7.5. So that means that is 7.5 times the 2. So that means to finish my square, I need to square 7.5. Keep in mind that square term is always, always positive. The number added to the end is always, always positive. So 7.5 squared happens to be 56.25. All right, on number 2, Noah was using the quadratic formula to solve 2x squared plus 3x minus 5 equal to 4. When he checked his answer, he found that, so he found x equal to negative 2.5 or 1, but he tried plugging back in and found that neither of those numbers actually worked. He wasn't getting the right answers. So he wanted you to check his steps. So here are his steps down here. He has a is 2, b is 3, and c is negative 5. He gets negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 5 all over 2 times 2. That becomes negative 3 plus or minus the square root of 49 over 4. And so square root of 49 is 7. And so negative 3 plus 7 is 4 over 4 is 1. Negative 3 minus 7 is negative 10 over 4, which is negative 2.5. So his big problem here, if you go back to the beginning, notice it wasn't equal to 0. It has to be equal to 0. Noah did not set the equation equal to 0. That was his mistake. So, set it equal to 0 and you can solve it. So to set it equal to 0, we subtract 4 from both sides and get 2x squared plus 3x minus 9 equals 0. And now we can plug it into our quadratic equation and simplify. So now our a is 2, our b is 3, and our c is negative 9. So we get negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 9 all over 2 times 2. And we're just going to go ahead and finish reducing this. So I get square root of 81, and the square root of 81 is the square root. It is 9. So I get negative 3 plus or minus 9 over 4. And I'm going to break this up into my two equations, one with addition, one with subtraction. So 6 over 4 can cut in half to be 3 over 2. Now in my other one, negative 12 over 4 can become negative 3. All right, so on the next set, I'm going to solve some of them completely for you. The others, I will just give you the answers. Keep in mind on them, before you use a quadratic equation, you need it equal to 0. I'm personally going to go ahead and use quadratic equation on all of these, but make sure you set it equal to 0 first. So on all of these, I will set it equal to 0 first and then apply the quadratic equation. So I ended up with 0 under my square root, so the square root went away. So I just have 2 over 2, which is 1. So x equals 1 is my solution for A. B, again, I have to get it equal to 0 first. So on B, I've got to get it equal to 0 first. That's why I'm subtracting 23. So I end up with x squared plus 8x minus 9 equals 0. Okay, so I break it up. I divide them both by 2 to get -4 plus or minus 5. And that breaks into two equations, one with addition, one with subtraction. So in this one I get two answers. I get the answer of 1 or -9. 1 or -9. All right, so I'm going to go ahead and just give you the answer for the rest of them, but keep in mind on one like C, A is 1 and C is -15, but the X term's missing, so we say it's 0. So if the X term's missing, we say our B is 0. So go ahead, check your answers with what I'm going to write here. For C, it was plus or minus square root of 15. For D, your two answer choices are -5/7 or X equals 1. And on E, your answer is -3 plus or minus the square root of 13. You just leave your answer like that because square root of 13 can't simplify. Okay, so number 5 is a review. So we have a negative under our square root. So that means I have -1 times 23. Keep in mind the square root of -1 is our definition of our imaginary number I. So I get I square root of 23. The 23 stays under the square root, so my answer is D. So if time allows, go ahead and do number 7 now. The answer to number 7 I will go ahead and write on here. All right, so here are the answers for number 7, if you have time allowed to try them. Have a lovely day.